high pressure has been over the west, and that has been bringing in unusually hot temperatures. In fact, yesterday, just west of Los Angeles in Woodland Hills, the temperature rose to 121 degrees. Now, what's interesting is that just up the road, Santa Barbara, temperatures stayed in the 70s. And so I want to use this weather pattern to explain what's going on and also explain adiabatic heating and cooling. So let me just show you the pattern. Here we go. So this is looking at 500 millibars. And what we do is we send up weather balloons once a day. When it gets to the pressure of 500 millibars, it makes note of how high it is. And then we draw a constant pressure map. And you'll see, so here's California, Nevada. We have high, the center of the high just between the two states. And this is the ridge line right here. And think of that like a mountain of air. And that air is sitting over the top. And the more air you have stacked on top of you, the higher the pressure is going to be, which will force the air down towards the surface. And when that happens, we get the air heating, because as it goes closer to the ground, it's going to encounter greater pressure, which will push on it. And we know from the ideal gas law that if you decrease the volume, the temperature is going to increase and can increase quite significantly. So I was driving last night, coming home from Lompoc, California, coming through the 101. And if you look at this map here, you can see the Santa Ynez Range. And so the 101 goes through and then along the coastline towards Santa Barbara. 9 p.m. at night, this was the reading that we got, 106 degrees. And see, I used the best scientific equipment I could. I'm using my car. And so drove another 14 miles, and the temperature dropped to 77 degrees. It was dropping at a rate of 2 degrees Fahrenheit per mile. So in just 14 miles, we were down to 77 degrees. So how can you get such incredible temperature contrast? You don't normally see this in places other than where you have a strong cold front, and that's not what was happening here. Okay, so if you remember back to the map, the windy map, it showed that the winds were coming from the northwest, kind of light winds, nothing very strong. But then as they hit this range of mountains, they're forced to go through the canyons and up and over and down on the other side. So as that air is pushed together, compressed, squeezed together, the temperature is going to rise. And also, the winds are going to increase. And you can see that very clearly here. Look at how 25 miles per hour. But then, down along the coastline, away from the range, here we have the Santa Barbara Lighthouse is only at 2 miles an hour, and it's coming off the ocean at that point. And so there's a huge difference in temperatures. So cooler air from north of the Santa Ynez Range. It was still pretty warm here because that was an interior air mass. But then as it goes up and over the range, compressed on the other side, look at the temperature readings you're getting. 98, my car was 107, and that was at 9 p.m. at night. But look then down at Santa Barbara, only 69 degrees. And that's because of the marine influence. We have in California cold ocean water that runs along the coastline, which cools the air right above it. So if the winds are coming off the ocean, it will keep the temperatures quite a bit cooler. Just look at this. So this is Gaviota. That was on the west end of away from Santa Barbara. The temperature yesterday was up at about 114 degrees. And then this is the Santa Barbara station, the weather flow station, that is just barely off the coastline there. So it's under the influence of the marine air. And you can see that most of the day it stayed in the 60s, with just a few hours topping over 70 degrees. So that just shows you what can happen here when we have that warm air. That air is then warmed adiabatically as it's pushed to the surface by the high pressure system and then going over the terrain. And then also what happens is we have the marine air taking over. And that's happening now. We're switching over to some marine air starting to move in. And so temperatures right close to the coastline are starting to cool down.